All right, the next one. Davin, be my narrator again. What do we got here?
Let f be the function given by f of x equals 300x minus x cubed. On which of the following intervals is f increasing?
Thank you. So I didn't include those intervals, but we can still figure out when f is increasing. Okay, so now keywords here, I annotated increasing for you. So that tells me that we're going to want to find f prime, the slope. So this is going to be our first derivative test again. Okay, to know when it's increasing, all we have to do is find out when things are positive on our number line. Okay, so that's another annotation. We can say when f prime is positive. That's what we're looking for here. So for this one, we can get started, and then I might move past this one. Let's go to India. Really quickly, what's my first step?
Find a derivative.
Yep, what is it?
X squared. X squared plus 300. Negative x squared plus 300.
You're really close. I got
3x squared. Negative 3x squared plus 300. I can't do it that way.
You wrote this the other way, and that's absolutely fine. You can change the order of that if you'd like. And then India, what am I going to do with this to kind of finish the first derivative test?
Divide it, find a common denominator.
Yep, find that GCF. That's going to be key in factoring, but I was just looking for a set of equal to 0. But yes, you're one step ahead of me. This is going to help me find my critical numbers, not my max min. So from here, Mike, what can I factor out? What's my GCF?
3.
Yep, that's it.
Yeah.
Okay, then from there, I'm just going to solve this the rest of the way. And I'm going to get 3 times, well, these are each perfect squares, so 10 minus x and 10 plus x. India didn't like that because she doesn't like how it's written backwards, but we'll still get the same solutions here. India, what are my 2 solutions to this?
X equals negative 10, x equals positive 10.
Yep. So those are going to be my 2 solutions. Notice how we won't have an extra solution on the outside because there's no x term on that 3. So boom. Now I have to set up my number line again. So in order to find increasing, decreasing, we have to figure out what to plug in here. So let's go to Davin. What 3 numbers could I plug in? Give me 1 for each interval.
Negative 11.
Perfect. What else?
9. 0.
Yeah, 0. Good. 9 would have worked, but 0 is better. What else?
And 11.
Perfect. Now, the one thing that I'm going to have you guys do on your own is we are going to plug this in to this right here to find that positive negative. So we can start with finding f prime of negative 11. And make sure that you include the minus sign and the negative 11 when you plug that in. And then the 10 minus 11 here. So including signs from the derivative and the negative 11. So that's going to give us a positive, and a negative. That gives us a negative. So Davin, what does that tell me? If f of negative 11 is negative, what does that tell me?
The graph is decreasing. Negative 11. Well, from infinity to negative 10, the graph is decreasing.
Really well said. It's decreasing from negative infinity to negative 10. All right. Now we're looking for things that are increasing. So you'd have to retry again and look for which intervals are going to be positive. I'm going to have you finish that one on your own. Maybe you need to write that on your sheet so that you can see that before you go on. But the next page is going to be the second derivative test. So questions on the first derivative test before I move on? Okay. Do not hesitate to raise your hand at any point. But we're going to go on to the second derivative test. So let's just go to the chat. In the chat, tell me one key word for the second derivative test. What is the key word that I'm going to be annotating for the second derivative test? So the first derivative test was extrema, increasing, decreasing. What about the second derivative test? There's a couple different keywords that I could be looking for. Go to the chat, put them in there. Someone said horizontal tangent, but that would actually be first derivative test. Max and Min. Zymera's got it. So let's see, second derivative test. What does that tell us? Zenaria and Zymera have chimed in. Let's get some more people in here. Davin, awesome. Kyla, awesome. Either we're sleeping or we don't know this one. Go to the chat. You can see in the chat what I've got here is I got two great answers, one from Kyla, one from Devin. Kyla, how would I know if something was concave up versus concave down using the second derivative test? How would I be able to figure that out?
Finding the sign of before and after
Mm-hmm.
a specific point.
Yep. And I'm actually going to say it's even easier than that. This is like the version of increasing, decreasing. So concave up is going to be when f double prime is what, Kyla?
Increasing.
Yep. So it's going to be positive, right? So I could say when f double prime is greater than 0, a positive number. So then concave down, Kyla, how would I know that? When f double prime is doing what?
Decreasing.
Yeah, less than 0 or a negative number. Davin, tell me what you know about inflection points.
Is where it changes the concavity?
Perfect. We're going to write that in there. And there's one more thing. Do you remember the other thing? It has something to do with f double prime equal to one number. What number would it have to be equal to?
0?
Yep. Perfect. Thank you, Devin. Thank you, Kyla. So the second derivative test is used to find concavity or inflection points. So that's how it's a little bit different. So it's one extra step. We have to find the derivative of the derivative, and it actually tells us some different things about it. All right, so it's going to be very similar to the first derivative test, but the first step is obviously going to be to take the second derivative. So we'll say take f double prime. And then basically we're just going to repeat those steps from that first derivative. Okay, so keywords concavity and inflection tells me double prime. Okay, let's go to a problem. All right. Our first problem like this, Davin, my narrator, go for it.
Let f be the function given by f of x equals x² minus 6x². The graph of f is concave up when
All right, perfect, Evan. Tell me what word I'm going to annotate.
Concave up.
Perfect. And I know that we already expect to use this, but that's going to tell us that we have to use the second derivative test. All right. So that's going to be when f double prime is greater than 0, or when f double prime is positive. So this is a key jump for me, and this is a key point of understanding. Not just that I need to use the second derivative, but that I need the second derivative to be positive because it's specifically telling me concave up. All right, so look for those keywords, dig for them. It's going to unlock the entire problem. So we've got to start with the first derivative. We don't have the derivative yet. So Michael, I'm going to you. What's my first derivative, Mike?
It is 3x squared minus 12x.
Perfect. Now, we're not done yet because we got to do that derivative again. It's the second derivative. So Mike, give me the second derivative.
6x minus 12.
Perfect.
Yes, sir.
Just like that first derivative test, we're still going to set this equal to 0. But we don't need to factor a GCF to solve this one because this is not a quadratic. This is not a cubic. It's not a polynomial. This is a linear function. So we can just add 12 and divide by 6 to solve this one. And we get x equals 2. Now, the unfortunate thing is this is not our answer. This is just a possible inflection point because the second derivative is equal to 0, right? We know that f double prime of 2 equals 0 because we just set that second derivative equal to 0 and we work backwards to solve it. But we can actually figure out to the left of 2 and to the right of 2, is it positive or negative? So just really quickly, we're just going to plug in some numbers. So I'm going to go to Zymera. Just tell me how I'm going to finish this problem, Zymera. What am I going to plug in?
You're gonna plug in 2 to the. Oh wait, hold on. What? Don't you gotta put? Oh, I don't remember.
Okay, so we've got 2. That's a critical number, but we already know that if we plugged in 2, we would get 0. That's an inflection, a possible inflection point. So just give me a number to the left and to the right of 2, Zymera.
1 and 3.
Perfect. So if we just plug those in as like test numbers, that's going to tell me what's happening to the left and what's happening to the right. All right, because it's concave on one side, it's concave on the other. 2 is where it changes, right? That's our inflection point, possibly. So we're just going to plug that in. And we're going to plug that into our second derivative. That gives me 6 minus 12, which is, it's negative 6, but let's just pick out the key information. It's going to be negative. And let's go back to Kyla. If I know that that's negative on that interval, does that tell me concave up or concave down?
Down.
Concave down, right? Thank you. So Zymera, we found concave down to the left. So now what's that last step that I'm going to do?
Just plug in 3.
Okay. Perfect, thank you. And Zymera, you're going to finish this up. What do I get when I plug in 3?
6.
Which is
Positive.
I need to plug in, that's a positive. So what's that tell me, Zymera?
It has an effect. 2 is an inflection point.
That is an inflection point because it changes concavity. But let's go back to what the question was asking us. They want to know when the graph of f is concave up. Do we have that information now?
Yeah.
Yeah. Since we've taken the second derivative that tells us concavity, how would I write that? How do I write something like anything to the right of 2 would be concave up? What's that interval look like, Zemra?
Negative infinity to 2.
You got that a little bit backwards. 2 is like our smallest number. So we're going to start with 2 and we're going to go 2.
Oh, you said anything positive, you said?
Yep, anything to the right of 2 is going to be concave up.
Oh, so 2 to infinity.
Perfect. Yeah. Okay. So that would be our answer for that one. And I would just want you to reflect on the fact that, okay, it was asking us about concavity. That told me that we needed the second derivative, and specifically concave up told me the second derivative had to be positive. So remember that this is like our living study guide. You're going to see an example similar to this tomorrow on the quiz. So have this in front of you. You can use your notes for the quiz. That is allowed for quizzes. So keep this in front of you as your living study guide and an exemplar when you're trying this on your own tomorrow. Are there questions about the second derivative test before I go on? Okay, you can always chat me up afterwards or kind of hang on the line if you have individual questions. Okay, Davin, my narrator, go ahead. Last one here.
What is the x-coordinate of the point of inflection on the graph y equals 1/3 x cubed plus 5x squared plus 24?
Wonderful. And Davin, while I got you, key word to annotate.
Point of inflection.
Yes. Davin, what's one thing that I need to find a point of inflection? What's one thing that has to happen?
F double prime has to equal 0.
Yes. And what else?
F double prime is
Something has to change. What has to change?
Direction. Concavity.
Concavity, yes. Wonderful. So we're going to still do the second derivative test. And we have to not only solve for when this is 0, we have to make sure that concavity changes either from negative to positive or positive to negative. Concave down to concave up or concave up to concave down. So this is one, let's just say we would find y prime first. If I bring this 3 down, we're just going to get 1 times x squared, bring the 2 down, 10x. And if we do double prime, we get 2x plus 10. All right, so once again, double prime because we're talking about concavity. And then this one we'll try to get through this one super quick. Brandon, let's see if you can do this in your head, Brandon. What would be my solution to this equation right here if I set this equal to 0?
It would be -5.
Perfect, right? Subtracted 10 in his head, divided by 2. Thank you, Brandon. Now, what we might be inclined to say is that is the inflection point, because we know that because we know f double prime of -5 is 0. That is one key thing. But what we also have to check is, just like before, we have to check our number line to make sure it's changing concavity. So this is where you'd actually have to redo this. Plug in this -5 into that 2x plus 10. And I'm going to do this part for you. So let me zoom in here, just in the essence of time. Oh, we don't want to plug in -5, Kirsch. We want to plug in like -6 and -4. One to the left and one to the right. Well, no. So that gives me a -12 plus 10, which is a negative number to the left. And if we plug in a number to the right, we would get 2 times -4 plus 10, which is -8 plus 10, which is a positive. So it goes from concave down to concave up. It definitely does change inflection. So I have just proven that there is an inflection point at x equals -5. You might be reflecting on, was all of this necessary off to the side? Yeah, it was, all right? Because if I got a negative and a negative, then -5 would actually not be an inflection point. It had to change concavity in order to be a point of inflection. All right, we've got 3 minutes left here, which means I do actually have time to talk about this very last problem, which I know has been a struggle for us, and 2 things that you can expect for today, to kind of go ahead and finish some of these things. But also, I'm going to be sending you emails with feedback on previous assignments. If you want to make corrections on those assignments and resubmit, you can increase your grade on those. Now I'll put those in the grade book. Just follow up with an email about those. So the first one on that last problem is just asking us at what values does f have a local maximum? And I think that for some of us, this has been a challenge because maybe people would be saying here and here, but remember that this is f prime. So this is where I'm going to have you refer to these notes, okay? We want to know, when does f have a local maximum? So you can look at your notes. Our original has a max when the derivative is 0, and it goes from positive to negative. So when the derivative is 0, it'll actually be on the x-axis. Positive to negative is going to be above to below. So let's see if we can find when the derivative is 0. Here and here, and here. But which one of those goes from positive to negative slopes? See, this goes from negative to positive. This goes from positive to negative, and this goes from negative to positive. So in something like this, x equals 6 is a local max. And I'll get to that question in a second, Mike. Because f prime is 0 at x equals 6 and changes from increasing to decreasing. So I'm saying very specifically, x6 is a local max. That's what it asked me. And I'm referring to my f prime to answer this. So f prime is 0, and maybe I should say, and f prime changes from increasing to decreasing. Okay. So that's just an example, and then once again, I'm going to have you refer to this. There are several different videos that have these notes in them. I may post this as just kind of a, make sure you have this for tomorrow guide, but it's 8:50. So I appreciate all of you that stayed here for the duration of this 50 minutes. I hope you found it helpful, not only from a standpoint of trying to get some of your work done for you. You probably only have 10 minutes of work left today for math, and it'll be well worth it to prepare for tomorrow. And I hope it was just good review. Can you show the notes again, please? You must be talking about this, Edward. Is that correct? And then, Mike, go ahead, unmute yourself. What was your question?
Oh no, never mind. I was just wondering, like, what's the homework? So like,
so you just got to finish this. So you've got two more problems here, B and C, right?
Okay.
Where you've got to kind of use these notes to help you annotate your graph and answer some questions.
Okay.
And I think I had you finish problem number. Didn't I have you finish one?
I believe so.
You had to finish problem number 2.
Oh yeah, and that. Okay, bet.
So I think there was like 5 total questions here. You've got to finish 2 and 5. So that, I really think that'll only take you 10 minutes.
No problem. Thank you, Kirsch.
You're welcome.
Yeah.
You're welcome, Edward. Are there any other questions before we all take off and enjoy the rest of this beautiful, what day of the week is it? Does anybody even know what day of the week it is? Is it Wednesday or Thursday?
It's hump day.
It's Thursday?
Wait, Mr. Kirsch.
It ain't Thursday, is it?
It's hump day.
Wednesday.
It's Wednesday.
Wait.
It's just,
Mr. Kirsch, I have a question real quick.
before I get to you, Zabari, Davin, your homework was to finish the assignment I posted. So it would be to finish question 2 and to finish question 5, this graph. Okay, Zabari, go for it.
Never mind, you answered it.
Okay, great. I will post this video, hopefully, if you guys want to go back and if you missed some things from class, but it'll be a long video, but it'll be up. We missed, I forgot to hit record on the first question. So, yeah. Zabari, you know that there's a quiz tomorrow?